The sharing organised here. Okay, this is basically where we left off at the end of Tuesday's lesson. And we're going to look at other vital parts that comprise a PC. Before I do that, taking you back to the case of the computer. I don't know if you can see that. There's a lot of light flying around the room, but it's always in the wrong place. In the back of the computer, there's some cables. I don't know if you can see those at a distance. These are always in the case. If you're building a computer, you buy a case, and those cables connect to the switches that are on the front panel of the computer. So the on-off switch, perhaps a reset switch, some LEDs there, the power, the hard drive LED, and so on. And they need to be connected to the motherboard, and and when you buy your motherboard, you will get a book, and it will show you the edge connectors around. All they are pokey up pins. They're just pins sticking out of the motherboard, and the plugs on the cables are designed to fit directly onto those pins. You just need to plug the right one in the right place. Typically, I say typically because everybody can make mistakes, but generally the connectors are designed to only fit the right place, with the exception of the ones that come from the case, because there's lots of connectors on there which you could put them in the wrong place. They are actually labelled on the motherboard. There's little names by the plugs themselves, but you need to make sure you read the book and plug them in the right place. Otherwise, of course, the on-off switch won't work, or whichever one you've plugged in correctly. Right, let's move on now. Power supply units. They all look much the same. There is a power supply unit, and coming from the power supply unit is a wiring loom with lots of connectors on the end. And the connectors that are on the end look much like that. Now, the important thing about these connectors are they're designed so that you cannot plug them on the wrong device. So if you're using a hard disk drive, I've got a hard disk drive there. On the hard disk drive, the power connector is a 4-pin connector, and there is only, on this particular one, there's 1, 2, 3, 4 of those, and they will fit on any appropriate device and they will work. So appropriate devices are, for instance, a hard disk drive, a CD-ROM, a DVD reader, DVD writer. All the devices that require that power have the appropriate socket on. So you cannot plug, for instance, a floppy disk into a hard drive cable. You cannot physically do it, so you can't break it, you can't get it wrong. So if you are thinking about building a computer, and I would recommend it, it's good fun actually, it is very, very straightforward, and you almost can't make a mistake. Right, so what have we got here? We've got 4-pin floppy power connector, and that's a very, very small one. As you can see there, it's got 4 pins on it. There's a larger one with 4 pins, but you can see physically that's the one that fits in a hard drive, and the one that fits in a floppy disk is much, much smaller. You cannot connect them up wrong. CPU power connector, 8-pin, and there's also a 6-pin one. You can't put them in the wrong place. PCIe, that's Personal Computer Interface Express. It's a more modern one than was fitted to earlier computers. That's a 6-pin connector. It will only fit onto PCI Express devices. The main power connector to the motherboard is 24 pins. So it's a parallel set of connectors. So there's 11 on one row and 11 on the other row. And you can't get it, you cannot connect it wrong. You can't put it in the wrong way. You cannot do it wrong. The final one we've got on here is a SATA power connector. And you'll hear me talk about, we're going to talk about disk drives in a minute. And there's PATA, P-A-T-A, and SATA, S-A-T-A. The ATA stands for the same. It's Advanced Technology Accessory. The S stands for serial. The P stands for parallel. Earlier devices were all PATA devices. They were all parallel connectors. And those devices use a 4-pin Molex connector. That's that sort of connector. 4 pins on the end. 4 pins on the end. Goes for PATA devices, which includes CD-ROMs and CD rewriters, DVD players, etc. The SATA, however, is different. And we're going to be looking at the SATA and PATA devices. There's a slide coming up showing the difference quite clearly. That is a much smaller power connector. You can't connect it to the wrong device. In fact, you can't connect a SATA connector to anything else other than a SATA device. You cannot do it. Permanent storage. Okay, we've mentioned RAM on the motherboard. That's temporary storage or main storage for the motherboard. We've got hard disk drives, which is essentially a bit like a record player, but fundamentally different. A record player uses a spiral track going from the outside edge to the inside, and your needle sits in it and it gets dragged along while it's playing music. Hard disk drives are completely different technology, apart from the fact the platter spins round. We're going to look at them in very great detail shortly. Solid state drives. They have now replaced hard disk drives. They tend to be reliable because there's no moving parts. So they're also faster because with the hard disk drive, as you'll see, there's a physical movement of the head to read data. With the solid state drive, there are no moving parts, so it's all electronically addressed. We've got CD and CD rewrites. These are what's called optical drives. They have a platter much like the hard disk drives, but the hard disk drive is a metal platter with a silvering surface on it. The CD and CD rewrites are optical drives, so it's a plastic thing with a thin film of metallic substance inside it, and it works by optics, a light literally shining on the surface. Similar to hard disk drives, but it's optical. It does not use magnetism. The fundamental energy or recording in hard disk drives is magnetic. DVD, digital versatile disc, they're very much optical as well. USB, very recent innovation. Well, I say very recent. Given my lifespan and when I started building computers, it's recent. Universal serial bus devices, many of them around, everything from little memory sticks, which I'm sure you're familiar with, and a lot of the devices we're talking about in terms of CDs, disk drives, etc., you can buy all the same devices with a USB connector, so they can be external to your computer, and they just plug into any USB port that's available. When I say any, since USB was invented, they have up the speed of the USB interface, and you now find you'll get a computer with different coloured USB sockets, blue, black, red, green, I think. Blue is the common one, which is USB 2, I believe. But you need to plug the USB device in the appropriate socket for it to work at best efficiency. It will work if you plug it into any one. If you've got a USB 3 device, which works at high speed, and you plug it into a port on your computer that's only a USB 1, it will only work at USB 1 speed. Okay, let's move on quickly because I've got a lot to cover. There's a picture of a hard disk drive, and I have one in front of me. I keep holding it up to the screen, whereas the camera's down there. So there you can see a nice shiny disk in there. This one's actually only got one platter in it. On the top of the disk, let me get a pointing stick. On the top of the disk, you can see a bar coming out to the middle. At the end of that is the actual head, the reading device that's going to read the data. And that head will swing. So it will swing, slide across the surface, driven by the disk controller. So when you request data from a disk, your operating system has to go away and find out where that data's stored on the disk. I've got a good slide showing you how data is stored a bit later on, but we'll come back to that. But it's not it's not quite as straightforward as it sounds. Most disk drives, most computers with disk drives use what's something called a file access table. And when you ask for the address, the disk address of the pieces of data, you have to give the cylinder number, which is the track that it's on, and you have to give it a certain segment address, which is the part of that cylinder. I'll explain it when we get to the diagram, it's easier. That is a SATA drive, and I can tell that. In fact, I'll do the SATA-PATA comparison in a minute, but I can tell you that's a SATA drive based on the size of the connectors there. And let's have a look at now. There's mentioned there just SCSI, Small Computer System Interface. I'll talk about that. We're not covering that in this lesson, but there is another type of hard disk drive, typically only used in business machines. Having said that, I bought a laptop a few years ago, and that had a SCSI drive in it, which did surprise me, actually. Okay, here we go. PATA, SATA, and SCSI. So PATA is Parallel Advanced Technology Accessory, old technology nowadays. SATA, Serial ATA, new technology, now quite common. SCSI, Small Computer System, is not shown, but it's mainly business systems that use that. Right, on the right is the PATA. That big long connector there on the left is 40 pins, and it's the data. That's where the data goes in and comes out of your drive. The connector on the right is a 4-pin Molex socket, and they're the ones that will connect where you connect your power supply into that drive. The SATA, on the other hand, has got a much smaller data connector and a much smaller power connector. So straight away you can see there's a visible difference between the two. Now this is a schematic of how the thing works. There's your processor and main memory in your computer, and there's a device called a disk controller. And the processor will send instructions to the disk controller to tell it where to go to get the data. And it will move the heads in and out or side to side. It will move them to find, excuse me, finds the correct cylinder where the data is located. Now these are going to rotate. There's three platters here. One I showed you earlier, just a single platter. This one's got 3 platters in it, and the surfaces are numbered 0 to 5. So the disk drive motor is going to run all the time. It's going to be going around all the time. All the time, the whole time that your computer switched on, to be perfectly honest. The big problem with hard disk drives is they're subject to having head crashes. And that is, although it looks like the head is touching the surface of the disk, it's not. It's actually flying at a very, very low altitude over the disk surface. When the disk spins, obviously air moves, it spins air as well, and it uses that air pressure to actually float above the disk surface. You get a head crash when the head lands, so it actually touches the surface, and you can normally hear it. It will squeal at you, like it's actually skidding on the surface, even though it's in a metal box, fully sealed metal box. This one's obviously shown with the lid off, and this one's got the lid off. But you will actually hear it all the way from the inside of your computer in its own box. You'll hear it when it hits the floor, or it hits the lands on the surface. And it typically occurs when the PC is dropped on the desk while moving it with the power on. As I said, every time your computer's powered up, the hard drives are going round. Possibly anything up to about 7,500, 10,000 revs per minute. They're not hanging around, they're moving pretty quickly. And what it does, it effectively plows a track on the surface. And because it's a magnetic surface and you've scraped some of it off, you've actually scraped your data off. So you will probably find, depending on where the problem is, your computer might not even boot up if it's landed where the operating system is. If it's scratched the operating system off, then you haven't got an operating system to run your computer. If it's landed in a data area, then you will have a problem accessing your data. There are tools to check, to scan your hard drive. Windows actually comes with some of these built in. We're going to talk about that in the next lesson when we talk about tools. I'm going to touch on them in this lesson very, very briefly, but we're going to cover them in detail in the next lesson. Yeah, so to get a head crash, your computer's got to be switched on, and you've got to shock it by dropping it or banging it or if it's under your desk, you might kick it. It's very, very easy to get one to happen. Having said that, although data can be recovered by specialist companies, but they do charge a lot. And if all you've lost is your operating system, you will probably find it's cheaper to go and buy a new disk drive. You need to buy a new disk drive anyway, because you can never reuse that disk drive again. So you've got to buy a new disk drive anyway, and you might just as well buy a new operating system as well. Having said that, if you deal with, and this is a big, we're going to touch on operating systems a bit later on, and we're going to cover it in great detail in the next lesson. But if you deal with a reputable company, and I'm in that I'm talking about Microsoft. When you register your copy of Microsoft soft operating system, for instance, I'm running Windows 10 Professional at the moment, and I put a new disk drive in my machine. I put a SATA in instead of the original PATA, which is why I've got spare bits lying around. Because my copy of Windows 10 Professional was bought legally and registered with Microsoft, I don't even need a CD to reinstall my operating system. I use the serial number of my product, and they just give me another copy. So that's one reason for using a reputable operating system developer and provider. There we go, hard disk drive storage, right. So that's exactly, if there were lines on the thing, that's exactly what it would look like. Lots of concentric cylinders. So A, pointing to red, is a single track or cylinder. It goes all the way around. We've then got something called a geometric sector, which is literally just a part of the circumference. So B is a geometric sector, and in there will be however many cylinders there are on the disk. C is a disk sector, so that's that little piece of red that's within the blue section. And a cluster is a group of one or more disk sectors. Each disk sector stores a fixed amount of user accessible data, or the operating system. Traditionally, when that was first made, it was 512 bytes, a hard disk drive, and 2000 bytes for CD-ROMs and DVDs. Newer ones use bigger sectors, up to 4K disk sectors. The smaller 512 hard disk drive sector was a significant impact on performance, and we're going to discuss that a bit later on. Basically, to give you a pointer, if you've got 512 byte disk sectors and you want to store a 2000 byte file, you need 4 disk sectors. That's all very well and good if they're like those 3 there, they're consecutive. So once you've moved your head out to the appropriate cylinder, it can read those 3 one after the other, as fast as the CD is, as fast as the disk is rotating. However, when your disk gets full, you might find you've got 2 there and 1 over there. So this is on track, counting from the outside, 1, 2, 3. Let's say it's on this side of the thing and it's in 1, 2, 3, 4, 5. So it's about there. So it's got to go to there, read the first 2, then it's got to navigate to where the 3rd one is and wait for that to come around and read. so it slows things down. The access time for moving a disk head from one cylinder to another is about 40 to 50 milliseconds. Now, that's not a lot, is it? But it is if the file you're trying to get is broken into 12 fragments all around the hard drive, and they're all on different cylinders. It's got to know, it's got to spend 40 milliseconds 12 times to get to the right place to read the data. This is a typical issue that the hard disk drive suffers from. And there are tools, commercial tools. In fact, Windows comes with them built in, which is, I'm going to flag up Windows a lot as we go through talking about operating system, because Windows is actually very good. It's actually the most popular operating system on the planet. And there's a good reason for it, or several good reasons for it, actually. Right. The sector is the minimum storage unit of a hard drive. And most disk partitioning schemes are designed to have files occupy a whole number of sectors. So if you've got a file, there's an example down the bottom there. If you want to store a 10K file and the disk sector is 4K, you need a block of 3 to hold 10,240. So 409, so 4K plus 4K plus 4K, that's 12K bytes that you've used to store a 10K file. So you've wasted, because you cannot reuse half a cluster. You can't do it. So you've used 12K to hold a 10K file. So you've wasted 2,000 bytes that you can never ever use again. If that file extended, so if it grew to 10,500 bytes, it would use the space. But no other file can write into that space. Some of that space is used to store the ECC, error correction code. And this is something that's written along with the data to ensure data integrity during data reads. And there's a note there that error correction codes are not mandatory for solid state devices. They can be implemented, but they're not mandatory, because the solid state devices work slightly differently. If you want to store a 10K file, it will probably give you a space of 15K, and it will pad the extra bit out with zeros or something like that. And the static device can actually reuse that data, reuse that space. So they work very much differently. You don't tend to get fragmentation to the same extent with solid state devices. Prior to using hard disk drives, they've got to be prepared. And there's 2 stages for preparation. There's partitioning, which is dividing this complete storage area into useful chunks. So the example there is a hard disk drive might have a capacity of 512 gigabytes. It's conventional to create one large partition, or one partition large enough to hold the operating system, generously to allow for updates, say 100 gigabytes, and a second partition for just data. The first partition will be called the primary partition, and is the boot partition, the partition that the operating system will look to find its operating system when it boots up, when the computer boots up. And a second or more for data, which is called an extended partition. Once you've done that, you have to format both partitions separately. and that creates the file system, the actual storage area. Unfortunately, if you buy a new PC or laptop, the tendency for manufacturers is to provide the whole of the hard drive or static solid state drive as one partition. But there are utilities available to shrink the main only partition and then create a second or more partition. Let's just look at my computer now. If I flash up my Windows Explorer, there we go. There's this PC. In there, these are directories with data in. We've got 3D objects, desktop, documents, downloads, music, pictures, videos. And there you can see I've got Windows C, and I've got Windows Recovery Tools D, RE is Recovery Tools D, and I've got Data F. And I've actually got a USB drive plugged in, which I've forgotten about. I know what that's got. That's got photographs on it. I went away to my granddaughter's 7th birthday party, and I was nominated the photographer, and I took all the pictures, and that's what I'm delivering to them, a copy of all the pictures. Anyway, I'll ignore that. So that's mentioned there as a part of my PC. It's also mentioned separately because it is a separate drive. It's a removable drive. If I pull it out, it should disappear. There we go. It's gone. Okay. Windows C. Typically, if you install Windows, it always installs on the C drive. Historically, A and B were floppy drives that the operating system called A and B. And most computers you could have two in. But C was always the first partition to use for the operating system. I've never installed Windows on anything but a C partition, so it's probably not possible. We've then got Windows RE tools, recovery tools, and that's been given the letter D. And they always grow chronologically. Windows RE tool is a directory I don't have any control of. I can delete it, but that was put there by the Windows installation system, and it's recovery tools. It's tools that Windows will use if I have a malfunction. And I told you it always puts them in chronologically. And why is the next one F? Well, F is an extended partition that I've created to put my data on. So if I open that up, there's all my personal folders on my data drive. I call it my data. Always create one called data, which is where all my data goes, which makes backups very, very easy. I know once a month I have to back up my data drive, and I do that. I'll explain how I do that when we talk about in the next lesson. Why isn't there an E? Well, there is an E. The E is my CD-ROM, but there's nothing in it, so it doesn't know. It doesn't know anything about it. If I stick a disk in, it will probably wake up. Mm-hmm. Hear it reading the CD now, so it should light up in a minute. There we go. DVD, read, write, drive, E, and the label on the CD is reg card, which is an application I wrote, and we're going to talk about. Oh, where's my? We're going to talk about programming in second, third, fourth, fifth. In the fifth lesson in this, according to my paperwork, in the fifth lesson of this, we're going to be talking about programming fundamentals. And reg card is something I will use as a demo during that lesson. It's written in something called Embarcadero, which is a programming system. That particular copy is written in C++, but I've also written it in Pascal. And I wrote it for, my wife was doing a exercise class, and one of her friends was the instructor. And my wife was a, if you like, a supervisor, registrar, that's the word. And she was doing jobs with the list of students attending the class. And I said, what are you doing that for? You need a database application for that. And I wrote a database application. I don't know if they're still using it, but my wife's not doing the class anymore. So, but yes. So that's why there was no E. If I take it out, there it goes, disappeared already. Okay. What else? Let's get back to my presentation. SCSI. Right. These fast speed, and as I said, they can go up to 10. They're the fastest of the drives, 7,200 at 10,000 RPM. So the access time is relatively short, and the transmission rates are higher. They're high reliability. They're mainly used in medium and high-end servers and high-end workstation. They're low CPU usage because a lot of the processing, the data flow between the disk system and the computer is completed by dedicated controller. So the CPU usage of SCSI drives is extremely low. And very importantly, they're suitable for hot swapping. They've got support for hot swapping, which means if you've got 3 SCSI drives in your computer and one fails, you don't have to switch your computer off, get the screwdriver out, etc. They're normally fitted in a drawer, and all you do is you switch that drive off, you pull the drawer out, you put another drawer in, and you switch it back on, and it carries on working. It will automatically configure the drive to be a replacement for the other one in terms of the data on it, and etc. etc. Very, very clever fail-safe system. Solid state drives. I have one of those. This drive, well, let me get the, I know the lid's not fitted to it, but if the lid was on it, it would say it's an 80 gigabyte drive. And it probably weighs, well, I don't know, best part of a kilogram. That, not the big black shape. The big black shape is the frame it's loaded on, but the little silver bit that you can see there, that is a 320 gigabyte solid state drive. So 4 times the capacity of that big thing is that little thing. Solid state. Yeah. They all use a SATA interface, and they can be used as internal drive or USB drives for convenience. And I've got one of those somewhere. Oh, there. And there is one there. USB cable on the end, and that's a 3.5 inch. That's a 1 terabyte drive. and that's what I use to back up my data drive. And I put a little label on there, and every time I do a backup, I write on there the date of the backup. So I've always got a written record of when it was done. Particularly useful. While I've got my drawer open, here's an example of a DVD rewriter. So that can create DVDs, read DVDs, and it connects simply via a USB connector. Frightfully useful. Optical drive, CD-ROM or CD rewrite. Capacity 700 megs. Not massive, but useful for most things. Definitions are there. I'm sure you know what they are. There's a DVD player or a recorder, much like the one I've just shown you. And the various capacities of them are down there. They can be up to 16 gigabytes. And you can see the different types there. Single-sided single layer, single-sided double layer, double-sided single layer, double-sided double layer. It basically reflects the way the data is stored within the device. Graphics processing unit. I do have one of these in this computer because I think I mentioned last time I used to like Microsoft Flight Simulator, which needs particularly good graphics to display the scenery dynamically and other aircraft dynamically. The motherboard I've got does have an onboard graphics card, as do most nowadays, but it's not up to the mark when it comes to high resolution stuff. That one, graphics cards tend to run a bit hot, so that one's got 2 cooling fans on it. I think mine's got a little cooling fan on it, nothing like the size of that thing. And I was quite amazed to know when I started researching graphics processing units for this course when I originally wrote it, you can actually buy water-cooled or fluid-cooled graphics cards because they run that hot. Amazing. Peripherals. Right, this is about the end of the catch-up. Peripherals, VDU, yes, you've got to have one of those. Keyboard, mouse, microphone, speakers, camera, graphics tablet. I bought one to use as a demonstration when I taught the course originally. I could put it on now, but I will admit I'm absolutely hopeless with it. I can use a drawing package a lot easier than I can use a graphics tablet. But they are available. So that's that. Get rid of that. Right. I'm going to rush through this pretty quickly. We are going to be talking about operating systems. Let me move my power supply so I can read my paperwork. In the next lesson, we're going to be talking about operating systems and system tools. And I will probably do a demonstration of application software during that. So operating systems, we're going to briefly touch on now. Application software, we'll touch on now. Games, I'll only mention 2 because I'm not a big gamer. Operating systems. contain and manage all the programs and applications that a computer or mobile device is able to run. This means managing the software and hardware functions. Functions of an operating system include booting, which is the process of turning on the computer and powering up the system. Memory management, that feature controls and coordinates the computer applications while allocating space for programs. Loading and execution. Your operating system will load or start up a program and then execute the program so that it opens and runs. So that's the boot process. The different types of operating system. There's batch operating systems, time-sharing operating systems, distributed operating systems, network operating systems, and real-time operating systems. They're pretty much job specific. So I'm not going to go into the details of that, but be aware there are different types of operating system. The ones you're using on your computer is really, it's a real-time operating system, really, because it's reacting to what's going on around it real time. It's reacting to your requests real time. It could also be a network operating system. If you're running a small network at home, it doesn't take much to start building a network. I mean, I can access all my files from my mobile phone sitting on the chair next door. So I've got a network running at home. And we are talking about networks specifically according to my program, somewhere about the second half of April, we'll be talking about networks. Other operating systems, mobile operating systems and embedded operating systems. Mobile operating systems, you're familiar with, everybody's got a phone nowadays. Embedded operating systems you might not be quite as familiar with, but there are lots of devices that use embedded operating systems. Your refrigerator's probably got an operating system, an embedded operating system working in there. It will have something that's sitting there monitoring the temperature. If the temperature goes low, goes too high, it will start the cooling system up again. Central heating systems have got an embedded operating system. Microwaves, you know, your car, if you drive a car, it's probably got an operating system in nowadays. Common operating systems, MS-DOS, that's pretty much almost died a death. That was the first Microsoft disk operating system. I can remember using that, and it was very much command line. The graphics were minimal. You could actually write a game using MS-DOS, but it wasn't frightfully interesting. Ubuntu and Linux. Ubuntu is a flavor of Linux. Fedora is a flavor of Linux. Mac and OS, they're pretty much Apple specific operating systems, and it's something I've never dabbled with, I have to say. Microsoft Windows is the most popular operating system on the planet. Unix is a particularly good operating system, and Linux is loosely based on Unix. Android OS is a new one that's just come out, obviously, with from Google. Chrome OS, yeah, another Googly operating system. When we talk about operating systems in the next lesson, I will be concentrating on Windows and Windows tools. But during writing this course, I actually downloaded and installed Ubuntu on a laptop, and I tried to run one of the lessons on it, and for some reason at that time I couldn't get Zoom to install. But I'm sure that was 3 years ago. I'm sure that I could probably do that now, and that will be my intention, to run the lesson or a lesson for you on Ubuntu. I was very pleased to find that. Well, let's talk about free software and costing software. MS-DOS was proprietary, Microsoft Windows is proprietary, Mac OS is proprietary, Apple OS is proprietary. All those, and pretty much Unix is proprietary as well. All those you buy a licensed copy from the manufacturer, and when you do that, you get support from the manufacturer if something goes wrong or if there's an update. Security patches are a big update for Windows because it's, as I said, most prolific around the world, and everybody's trying to break into it. Things like Linux, generally all flavors, not 100%, but 90% of Linux operating systems are free. There's one or two that, because they offer support as well, will charge you a license fee for. Ubuntu is a free one. It's the most popular one that most people pick when they want to move to Linux. I was quite pleased when I was investigating it to find that there is, because it's open source is the word I'm looking for, because it's open source software, anybody can write an application for it and give it away. You can even write your own Linux operating system and give it away, which is where Ubuntu started. I was quite pleased to note that somebody had already gone to the trouble of generating all my favorite Microsoft applications to run on a Linux platform. I forget what the name of the package is, but there's Microsoft Office, which has got Word, Excel, PowerPoint, and so on. Well, there's a version that runs on Ubuntu that does exactly the same thing. It reads and writes Microsoft files, and it works. I ran it and it worked perfectly. So I'm quite pleased with that. Now, I've got a short video on, and that'll be the end of today's lesson, I think. How far we've got? Oh, we've got some work. Yeah, I'll show you the video. Game software, I only use two things: Microsoft Flight Simulator and Microsoft Solitaire on my computer. In fact, I've used Microsoft Flight Simulator for 2.5 years. Right, let's have a look at this video quickly.
Computers are used for so many different tasks. Playing games, watching videos, running calculations, communicating and collaborating. Computers today are a mixture of different types of hardware and software. But there is one program that brings them all together, and that's the operating system. To consider what the operating system is, let's go back in time to the invention of digital computers. They could handle around 5,000 complex calculations per second Impressive for the time, but today's supercomputers perform nearly 34 trillion calculations per second. Programs were written on punch cards, pieces of cardboard with holes. These were fed one at a time into the Central Processing Unit, or CPU, and enabled the earliest form of computer batch processing. In some cases, one person was in charge of making sure the cards were fed in correctly. Their job was to correct jams and schedule when the next program could be run. As computers became faster, they were able to process punch card tasks quicker than the cards could be fed in. There was another problem. Different computers' resources, that is, the components within them, such as RAM, and the devices attached to them, such as printers, were all different from one another. A programmer had to write very different types of programs specific to the machine it would be running on. Was it this card? Or that card? Oh no, it's all getting a bit complicated, isn't it? The solution was to write a brilliant piece of software called an operating system, or OS. The OS would take over the tasks common to many programs. Today, operating systems control the hardware of the computer. They manage and allocate resources and provide an interface for the user. Go on then, turn on that computer and we'll see what happens. An OS is one of the first programs that runs when a computer is turned on. Most programs start the same way. The computer issues lines of code as commands to prepare all the important elements, like the screen and the network. The operating system holds the collection of all the common commands and segments them, rather like putting them into a library, from which the other regular programs can borrow codes.
Hey. Right, we talked about game software. Let's go on. So an operating system acts as an intermediary between the user of a computer and the computer hardware, the purpose of which is to provide an environment in which the user can execute programs conveniently and efficiently. Right, I'll save this for next time because it's going to make me overrun otherwise. This is a bit more in depth about operating systems, and as the next lesson is about operating systems and system tools, we'll start with this video on the next lesson. So where are we? 10. Good. I'm glad that I knew it was in there somewhere, but I haven't watched that video for a while. I'm glad it mentioned punch cards because that was the way of computers working in the very first instance. Hence the importance of von Neumann when he came up with the stored program concept for operating systems, whereby the operating system is loaded once. Not every time you want to run a program do you have to feed in all the cards through it every time. You load it once, and then from then on, all the programs it needs are installed and ready to run. I mean, it'd be a bit awkward if every time you wanted to write a Word document, you had to reinstall Word. I mean, that's the kind of mundanity that the early computers suffered from. They could only do one job at once. Right, well, that's it for today. Have you got any questions on today's lesson, Joshua?
No, I don't have any questions.
Okay, well, I'll see you again next Tuesday.
All right, then. All right, see you.
Yeah, have a good weekend.
Bye.
Bye.